Dear students, welcome to Brilliant Qatar. Today we are going to discuss the physics questions from the Neet 2023 paper. As usual, physics paper was moderate. Many questions were easy, some questions were a bit lengthy, but altogether the paper was very easy. So we are going to the first question. Question number 1. The ratio of radius of gyration of a solid sphere of mass m and radius r about its own axis to the radius of gyration of a thin hollow sphere of same mass and radius about its axis is. So it's a question from, hope you understand, it is from class 11, system of particles and rotational motion. So it's a question based on rotational motion. They're asking ratio of radius of gyration of solid sphere to hollow sphere. So you know that. What is the moment of inertia of a solid sphere? Moment of inertia of a solid sphere, all of us know the formula. I of a solid sphere is 2 by 5 mr square. This is the formula for moment of inertia of a solid sphere. All of us know that. That means, what is the general equation for the moment of inertia? It is mk square. M is mass and k is the radius of gyration. So you can replace k square. K means k of the solid sphere square is equal to 2 by 5 mr square. M gets cancelled. So ks square is equal to 2 by 5 m is cancelled, 2 by 5 r square. So this is the relation of radius of gyration of a solid sphere with its radius. Now in the same way, we can write the equation for the moment of inertia of a hollow sphere. I am writing I of h hollow sphere. It's equal to, you know the formula, it is 2 by 3 mr square. 2 by 3 mr square is for a hollow sphere. So this hollow sphere, when you are writing the general equation, it is m into k of hollow sphere. K is the radius of gyration square is equal to what? 2 by 3 mr square. So m and m gets cancelled. We have k of hollow sphere square is equal to 2 by 3 r square. So this one we can take equation number 1, this as equation number 2, right? If you're finding the ratio of these two, they're asking the ratio of what? Radius of gyration. So I'm dividing equation 1 by equation 2. What will be the result? It is ks by kh square is there, right? Whole square is equal to, if you are taking the ratio, r square will be cancelled. It is 2 by 5 by 2 by 3. So we get it as what? 3 by 5. Remember students, 3 by 5 is the ratio of ks square by kh square, but they are asking the ratio of radius of gyration. So we have to find ks by kh, which means the answer will be square root of this. That means root 3 by root 5. This is the answer. Now looking at the option, you can see that that option is not there. That means the root is missing. See, 4, close answer, but the root is missing, which means for this question, the right option is not there. Right option is root 3 by root 5. So let's hope this question will be deleted. Anyway, let's see. So the right answer for this question is what? Root 3 by root 5. Clear? Now I'm going to the second question. Look at this. It's a very easy question. The work functions of cesium, potassium, sodium are 2.14, 2.30 and 2.75 electron volt respectively. If incident electromagnetic radiation has an incident energy of 2.20 electron volt, which of these photosensitive surfaces may emit photoelectrons? Listen, it's very easy. You can see that work function, look at that, 2.14, 2.3, 2.75, and energy of incident photon is 2.20. Question from dual nature of radiation and matter. You know that for there is photoelectric emission, the energy of incident radiation should be greater than the work function. That means this 2.20 should be greater than the work function. So if you are comparing the work functions, 2.20 is greater than only one. What is that? 2.14. So only the element with 2.14 electron volt has the work function will show photoelectric emission, which is that it is the first one, cesium, right? Cesium's work function is 2.14. So our correct answer is which one? Correct answer is option 4. It is cesium only. All right, it's clear, I think. I'm going to the next question now. Question number 3. The amount of energy required. The amount of energy required to form a soap bubble of radius 2 cm from a soap solution is nearly, and it is given that the surface tension of a soap solution is. Question from which chapter? It's from the mechanical properties of fluids. Work done, the amount of energy required to form a soap bubble. So we are forming a soap bubble, right? So what is the idea? Surface tension. You know that surface tension is equal to what? Surface energy. Surface tension is numerically equal to surface energy. What is surface energy? Surface energy is energy per area or work per area, which means surface tension, if I am representing it by the letter sigma, sigma is equal to what? Work by area. That means work done is equal to the surface tension into area. So what is surface tension here? Surface tension is, you can see it's given as 0.03. 0.03 into area. Area means there is a confusion. Please note that it's a bubble. Bubble has how many free surfaces? 2 surfaces are there. So when you're calculating the area, the surface area of the bubble into 2. So 2 into, what is the formula? 4 pi r square. 2 into 4 pi r square. You can substitute the value. So it is 0.03 into 2 into 4 into 3.14. Look at the radius. Radius value is 2 centimeters. So 2 into, it has to convert into meter. 2 centimeter means 2 into 10 power minus 2, the whole square. Okay, so you can calculate it. I'm not going to show the calculation here. The answer will be, you can see that it is 3.01 into 10 power minus 4 joule. That is the answer for this question. All right. So I'm going to question number 4 now. Look at this. Resistance of a carbon resistor determined from color codes is 22,000 plus or minus 5% ohm. The color of the third band must be, third band. Okay, question from current electricity chapter. Color code of resistors. Hope you remember this. See, look at the number 22,000 plus or minus 5%. So 22,000 ohm. How can you write 22,000? 22,000 is equal to 22 into 10 to the power 3 plus or minus 5%. Isn't it? Why are we writing like this? The reason is, you know that the third color is indicating the power of 10. So you can see the number, the power of 10 over there is 3. So 3 corresponds to which color? Hope you remember the color code idea. It is like this. This is the order, right? Etc. 0, 1, 2, 3, 4, like that. So we need which color? Which number? 3. 3 correspond to which color? Orange. So orange color is the answer, which means it is option 2. Option 2 is the right answer for this question. Orange. Understood? It's an easy question. Question number 5. In a series LCR circuit, the inductance L is 10 millihenry. The capacitance C is 1 microfarad. The resistance R is 100 ohm. The frequency at which resonance occurs. The frequency at which resonance occurs. You know that it's a direct question. Resonance frequency. From which chapter? Alternating current, class 12. What is the formula for resonance frequency? F is equal to 1 by 2 pi root LC. This is the formula. Substituting 1 by 2 pi root of L, inductance value 10 milli, 10 into 10 power minus 3 into C value, C is 1 microfarad. Micro is 10 to the power minus 6. So we get 1 by 2 pi into root of 10 to the power minus 8 will come. So it is 1 by 2 pi into what? Square root of 10 to the power minus 8 is 10 to the power minus 4. So this will go up. We get 10 raised to 4 divided by 2 pi. 10 raised to 4 is 10,000. 10,000 by 2, 5,000. So 5,000 divided by pi, which means it is 5 by pi into 1000. 5 by pi, 5 by 3.14. 5 by 3.14 into 1000. So it will be around 5 by 3, 1.5 something. So you can see 1.59 kilohertz will be the answer. Option 3, 1.59 kilohertz is the answer for this question. Going to question number 6. In a plane electromagnetic wave traveling in free space, the electric field component oscillates sinusoidally at a frequency of 2 into 10 raised to 10 hertz and amplitude is 48 volt per meter. Then the amplitude of oscillating magnetic field, it is given the speed of light in free space is 3 into 10 raised to 8. Another very simple question. From which chapter? Electromagnetic waves. In electromagnetic waves, see, amplitude of electric field is given, which means you know that amplitude of electric field is represented by E naught. E naught is equal to 48 volt per meter. Volt per meter. What they are asking, then the amplitude of oscillating magnetic field is, that means B naught only they are asking. We have a formula. What is it? E naught is equal to B naught into C. That means B naught is equal to what? E naught by C. What is E naught value? So B naught is equal to, E naught is 48 divided by C, 3 into 10 to the power 8. So we get 48 by 3 is 16 into 10 to the power minus 8. So look at the options, what you can see. Yes, it will be 1.6 into 10 to the power minus 7 Tesla. Yeah, option 2 is the right answer. Okay, 1.6 into 10 to the power minus 7 Tesla. All right, again a very easy question from the chapter electromagnetic waves. Look at this. Given below are two statements. Let's check which all statements are correct. Photovoltaic devices can convert optical radiation into electricity. Of course, it's a correct statement. Light is falling, it is converting into what? Electrical energy. So, photovoltaic devices can convert optical radiation into electricity. Zener diode is designed to operate under reverse bias in breakdown region. Of course, it is also correct. Hope you remember what is a Zener diode. It is a specially designed PN junction diode which is operating in, which is having a sharp breakdown voltage, right? It is to be operated in the breakdown region, which means both the statements are correct. Statement 1 is correct. Statement 2, it is also correct. So which is our right answer? Both statement 1 and statement 2 are correct. The right answer is option 4. Okay, I'm going to the next question number 8. The errors in the measurement which arise due to the unpredictable fluctuations in temperature and voltage supply are unpredictable fluctuations. There are different types of errors you studied. Instrumental error, least count error, many are there, but these are unpredictable, right? And you know the name of these type of errors is what? Random errors. Random errors are unpredictable, right? So which is the right answer? The right answer is option 3, random errors. Okay, easy question from the chapter units and measurements. Next, question number 9. Look at this. If integral E dot ds is equal to 0, integral, closed integral E dot ds is equal to 0, which of the statement is correct? That's what they are asking. Question from electrostatics, right? Integral E dot ds, what is it? You know that this is a formula for the flux. Electric flux phi is equal to integral E dot ds. So integral E dot ds is 0 means flux is 0. So in which case flux is 0? Very simple. Look at the option 4. The number of flux lines entering the surface must be equal to the number of flux lines leaving it. So 5 lines are entering, 5 lines are leaving. What is the net flux? It's equal to 0. So that's what the same situation. Integral E dot ds is 0 means phi is equal to 0. So phi is 0, in which case it is in the fourth question. So the answer is fourth option. This is the right answer for the question. Okay, number of lines entering is equal to the number of lines leaving. Going to question number 10. If the galvanometer G does not show any deflection in the circuit, then the value of R is given by. You can see that this is a electric circuit, right? There is a galvanometer. You can assume it is having some resistance, but it is given that it is not showing any kind of deflection. If it is not showing any deflection, which means the current flowing through that is 0, then what is the value of R? Do one thing. It is from which chapter? Current, electricity, Kirchhoff rule. So let us mark this point A, P, C, D, E, F. And let us assume the current flowing from here as I. So this is I, this is I. There is no current through this, so it is I, and will be going like this. I am applying the loop rule. Loop rule for the loop A, B, D, E, A. Let's apply the rule. What will be the result? We are starting from A. So going up, we get minus 10 volt, minus 10, plus 400I. 400I. There is no current through this path, but here there is a cell, so plus 2. Plus 2. Is there anything else? No, nothing. So it is equal to what? 0, which means we get 400I. 400I is equal to what? Minus 10 will come this side. Plus 10, minus 2, 8. So I is equal to what? 8 by 400. That means 1 by 50. 1 by 50 ampere is what? The current. Okay, but they're not asking the current, they're asking the value of R. Now, let us take the other loop, this loop, A, B, C, F, A. A, B, C, F, A. Again, we can apply the rule. We get minus 10 plus 400I, 400I, plus I into R, or R into I is equal to what? 0. Minus 10 plus 400 into, what is I? I is 1 by 50. Plus R into, again I is 1 by 50 is equal to what? 0. Okay, so we get 400 by 50 plus R by 50 is equal to 10, which means 400 plus R is equal to 500. R is equal to what? 500 minus 400 is equal to what? 100 ohm. So the answer for this question is 100 ohm, which is option 2. So a question, not a tough one, easy question based on Kirchhoff rule. Answer is 100 ohm. Clear? Right. Question number 11. An AC source is connected to a capacitor C due to decrease in its operating frequency. So this is an AC circuit with a capacitor. Look at this. Capacitor connected to an AC source. We are decreasing its frequency, right? Frequency is decreasing. So you know that in an AC circuit, a capacitor can offer a resistance. It's called capacitive reactance. What's the formula? XC is equal to 1 by C omega. Capacitive reactance. So this is equal to 1 by C into 2 pi F, which means XC is inversely proportional to the frequency. What does it mean? When frequency decreases, capacitive reactance increases. When frequency decreases, capacitive reactance increases. Look at the option. Capacitive reactance remains constant, capacitive reactance decreases, which means capacitive reactance increases. Such an option is not there. But you can think in another way. When frequency decreases, capacitive reactance increases. When capacitive reactance increases, what will happen to the current? Reactance is resistance. So when resistance increases, current decreases. Not that point. Frequency decreases, resistance increases. When resistance increases, current decreases. Current decreases means obviously displacement current also what? Decreases. So the right answer for this question is displacement current decreases. Option 2. Displacement current decreases. Clear? Question from alternating current, class 12. Okay, going to the next question, question number 12. The minimum wavelength of X-rays produced by an electron accelerating through a potential difference of V is proportional to minimum wavelength of X-rays produced by. So X-ray is produced by the acceleration of electron. So you know that if a charge is accelerated under a potential difference of V, the energy acquired is what? QV. This is a formula for energy, you know that. U is equal to, or E is equal to QV. But here, which one is accelerating? Electron is accelerating. So instead of QV, you can write what? EV. So this is the energy of X-ray. Okay, and energy of X-ray means, you know that using the idea of photon concept, energy is equal to what? H nu. So H nu is equal to what? EV. That means nu is C by lambda. So C by lambda is equal to what? EV. Here they are asking the minimum wavelength is proportional to wavelength and potential difference relation we need. So lambda is equal to what? HC by EV. That means lambda is inversely proportional to V or directly proportional to 1 by V, isn't it? So inversely proportional to V means, look at this, the answer is option 1. Option 1 is the right answer for this. Okay, clear. Question number, so this is from which chapter? Dual nature. Question number 13. Simple, direct question. Okay, the venturimeter works on. So these are question I think you can save the time a lot. Venturimeter. In fluid chapter, Bernoulli's principle, we studied a lot of applications, example, and one of the important application is what? Venturimeter. What is a venturimeter? It is a device which is, it's a measuring device to measure the volume flow rate. So the answer for this question is what? Venturimeter is based on Bernoulli's principle. Okay, Bernoulli's principle, you know the importance of that. Okay, right. Next question number 14. A full wave rectifier circuit consists of two PN junction diodes, a center tap transformer, capacitor and load resistance. Which of these components remove the AC ripple from the rectified output? Rectified output. So rectified output means rectification process is over. So you know that the purpose of diode, center tap transformer, everything is in the rectification. So rectified output is getting filtered. Removing ripple means filtering. That filtering is done by which circuit? You know that it is the capacitor filter circuit. So which device is removing the ripple? It is the capacitor. Capacitor. See, capacitor only. Okay, it's easy. Going to next chapter, a question from the semiconductor part. Next, question number 15. A metal wire has a mass of 0.4 plus or minus 0.002 gram, radius 0.3 plus or minus 0.001 millimeter, and length 5 plus or minus 0.02 centimeter. The maximum possible percentage error in the measurement of density will nearly. Percentage error. Question from what? Question from units and measurement. Error analysis. Percentage error. Do you remember how to calculate percentage error in a quantity? Percentage error is relative error into what? 100%. So here metal wire, radius is given, mass is given, length is given. Okay, and the percentage error in the measurement of density. What is the formula for density? Density is mass by volume, right? So density rho, if you are representing density by the letter rho, it is mass by volume. It's a formula for the density, isn't it? Yeah. Now it's a wire. So wire volume, how can you find? Wire is just like a cylinder. So volume will be base area into distance, length, which means R is the radius, means base area will be pi r square. So what we can write? Mass divided by pi r square L. This is a formula for the density. Pi is a constant. So we are calculating the error, remember. We are not calculating the density value. Percentage error, right? Okay, so hope you remember the formula. How to calculate percentage error? There are three quantities. Pi is a constant. M, R and L. What is the power of M? 1. So relative, I will be writing the formula for relative error. Relative error in rho is equal to power of mass is 1. So 1 into delta M by M. This is relative error in what? Mass. Plus radius has a power 2. So 2 into delta R by R plus Power of L is 1 only, so we get delta L by L. Remember, this is which error? Relative error. But they're asking what? Percentage error. How do we find percentage error? Percentage error means into 100% only. So we need to multiply all the terms by 100. So look at this, delta M by M into 100 plus 2 into delta R by R into 100 plus delta L by L into 100 into percentage. I mean this much of percentage. This will be the result. Now let's substitute. What is delta M? Check the given data. Delta M is, see, 0.4 plus or minus 0.002 means delta M is 0.002 into 100 means, I'm making the calculation simple, 0.002 into 100 will be 0.2. So first term 0.2 by 0.4. Okay, 100 I am taking here, plus 2 into delta R. Look at delta R, 0.001 into 100 will become 0.1. So 0.1 divided by what? 0.3. 0.3 plus delta L by L. Check delta L, 0.02 into 100 will be 2 by 5. 2 by 5. You can simplify it. 0.2 by 0.4 is 2 by 4, which is 1 by 2, plus 2 by 3 plus 2 by 5. Take 2 into 3 into 5, 30 as LCM. You get 15 plus 20 plus 12. So it is 30, 20 plus 15, 35, 30, 47 divided by 30. 47 divided by 30. If you are calculating, you can see that the answer will be around 1.6%. Yes, 1.6% will be the answer. Option 2 is the answer for this question. 1.6%. Okay, 47 by 30. Yeah. Now, is it clear? So, it is one of the lengthy calculation based question. Okay, right. But easy question only, but calculation is a bit lengthy. I'm going to the next question, number 16. Look at this. Again, there are two statements for Young's double slit experiment. Two statements are given below. If the screen is moved away from the plane of slits, angular separation of the fringes remain constant. Screen is moved away. See, in double slit experimental setup, see, two slits S1 and S2. If you are moving the screen away, they are saying that the angular separation of the fringes remain constant. Angular separation, angular width. Remember, angular width is independent of the distance between the slit and the screen. Linear width will increase, but angular width, angle remains same. So the statement 1 is correct. Correct. Now, look at statement 2. If the monochromatic source is replaced by another monochromatic source of larger wavelength, the angular separation of the fringes decreases. So when wavelength increases, what happens to angular separation? What is the formula for angular width? You know that linear width beta is equal to lambda d by d. Angular width is beta by capital D. So angular width is equal to lambda by d, which means you can see it is directly proportional to lambda. That means when the wavelength increases, angular width should increase. But in the statement, it is saying that the angular width decreases, which means statement 1 is correct, but statement 2 is false. Which option? It is option 2. Look at that. Statement 1 is true, but statement 2 is false. Okay, so this is the correct answer. Now, question number 17. Okay, look at this. The potential energy of a long spring when stretched by 2 centimeters is U. Potential energy of a spring. So now if you got an idea, this is from which chapter? From work energy power, right? Potential energy stored in a spring. If the spring is stretched by 8 centimeters, the potential energy stored in it will be. It's very simple. You can leave that 2 centimeters and 8 centimeters. Just trying to get the relation. What is the formula for potential energy? U is equal to half kx square. This is the formula, right? Half kx square, where k is the spring constant, you know that. So initially, what's the distance? 2 centimeters. That 2 centimeters is becoming what? 8 centimeters. 2 becomes 8. It becomes how many times? 4 times, right? That's the idea. So If initial is x, the new distance is what? 4 times the initial for x. So u dash, the new energy will be half k. Half k is a constant. But instead of x, what we can write? X is how many times? 4 times. So we get 4x the whole square. So we get 4 square is 16. 16 times half kx square. So half kx square is u. So look at the result. 16u. 16u. Option 3 is the right answer. Isn't it? Yeah. 16u. Very easy question. 16u. Going to the next. Question number 18. Light travels a distance x in time t1 in air and 10x in time t2 in another denser medium. What is the critical angle for this medium? Critical angle formula. Critical angle is, you know that, ND, refractive index of denser medium, by NR is equal to what? 1 by sine C. Okay. That means sine C is equal to what? NR by ND. That means this is in terms of refractive index. You know the relation between refractive index and speed, velocity in a medium. N is equal to C by V. So if you're using that idea, you can see that NR is C by VR and ND is C by VD. So we get this as VD by VR. Okay. So how do we solve it? Sine C is equal to VD, velocity in denser medium. In denser medium, it is given that it is covering 10x distance in time t2, which means displacement is velocity. Velocity is displacement by time. So we get 10x by t2 divided by, in rarer medium, x by t1. So we can easily solve it. 10x by t2 into what? t1 by x. X get cancelled. So look at the result. 10 t1 by t2. This is what? Sine C. Then what is C? C is equal to sine inverse of 10 t1 by what? t2. Sine inverse of 10 t1 by t2. Easy question from optics. Answer is option 3. 3 is the right answer. Clear or not? Yes. Question number 19. Look at this. A 12 volt 60 watt lamp is connected to the secondary of a step down transformer whose primary is connected to AC mains of 220 volt. Assuming the transformer to be ideal, what is the current in the primary winding? Ideal transformer. What is the meaning of ideal transformer? There is no power loss, right? Ideal transformer means input power is equal to what? Output power. So this is a very easy question. Look at the secondary winding. Secondary coil, what's the power? It is 60 watt. So in secondary, power is 60 watt, means in primary also the power has to be what? 60 watt, right? For that, in primary, voltage is given. Look at that. V primary is equal to what? 220. 220 volt. Okay, we have to find current in primary, IP only. What is the power in output? 60. Ideal transformer means output power and input power has to be the same. That means input power will also be what? 60. So power is equal to 60. You know that power P is equal to VP into IP. Which means IP is equal to P divided by VP. That is 60 divided by 60 by 220. So 6 by 22, right? 6 by 22. If you're calculating, you can see that the answer is 0.27. 0.27 ampere is the answer. Option 4. 0.27 ampere. Clear? Yeah. Question number 20. A football player is moving southward and suddenly turns eastward with the same speed to avoid an opponent. The force that acts on the player while turning is. So they are not asking the magnitude of force. Just look at the options. Only direction they are asking, right? Direction. See, we can analyze the question. A football player is moving southward and suddenly turns what? Eastward. So let us draw the normal direction first. This is north, south. This is west and this is what? East. This is what the standard way of marking the directions. Now the football player first is moving where? Southward. So I'll be showing it. Southward means it's going in this way. This is its initial velocity direction. After that, suddenly turns eastward. Okay, suddenly he is changing his direction towards what? East. So you can see the direction of velocity is being changed. That means if you are representing this one as V1 and this as what? V2, initial velocity and final velocity, they are asking the force that acts on the player. Force F is equal to ma, which means direction of forces in the direction of acceleration. So from this, what we have to find is the direction of what? Acceleration. What is the direction of acceleration? You know that direction of acceleration is in the direction of what? Change in velocity. Not in the direction of velocity, the direction of acceleration is in the direction of change in velocity. So initial velocity is down and the final is in this way. So change in velocity means it is vector v2 minus vector v1. This is the direction of acceleration is in the direction of v2 minus v1. v2 minus v1. v2 minus v1 is v2 plus minus v1. So this is v2. v2 you can keep as it is. v1 is down. So what will be minus v1? Minus v1 is up. So I'm drawing minus v1 like this. Look at this. This is minus v1. Then using the triangle law of vector addition, this is what? v2 minus v1. v2 plus minus v1, which is v2 minus v1. That means this is our direction of acceleration. Got it? Direction of acceleration is this way, means direction of force will also be in that way. Now what is this direction? Look at this. It is what? Along which one? Northeast. 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 So the answer is this one. Along northeast. Okay? Right. Question number 21. The magnitude and direction of current flowing in the following circuit is very simple. Kirchhoff's rule you can directly apply. We have to find magnitude and direction of current, right? Direction of current. I'm taking the direction of current is in this way. So I'm just applying Kirchhoff rule. Here, you can take current as I. So look, if I'm going from A, B, C, D, what I get? 2I minus 10 plus 5 plus I plus 7I is equal to 0. So you can see I have taken the direction of current like this, like in a clockwise way. I took like that. Okay. So 2I plus I, 3I plus 7I is 10I. 10I minus 10 plus 5 is minus 5. It will go to the other side, will become plus. So 5. I equal to what? 5 by 10, which is equal to 0.5. Remember, 0.5 ampere is the current. 0.5 ampere, there is only one option. So no need of checking the direction. Now how to check the direction? If there are two options with 0.5, it's easy because the way I took the current is like this, clockwise, and I am getting a positive number, means the direction which I have taken is correct only. So the direction is from A to B through E. So the answer is option 1, 0.5 ampere from A to B through what? E. Okay. Question number 22. The angular acceleration of a body moving along the circumference of a circle is? Easy question. What? It's just like direct. What is the direction of angular acceleration? Angular velocity and angular acceleration, everything you know that it's like along the axis of rotation only. If a body is rotating like this, the direction of angular acceleration is what? Along the axis of rotation. It is a basic idea. So the answer is option 3, along the axis of rotation. Okay, right. Question number 23. A bullet is fired from a gun at a speed of 280 meters per second in the direction of 30 degrees above the horizontal. The maximum height attained by the bullet, G is 9.8 and sin 30 is equal to 0.5. Direct question from what? Projectile motion, right? Projectile motion, you can see that U is equal to 280 meter per second. And the theta value is given as 30 degree. G, they are saying that you have to take it as 9.8. So what is the formula? What is the formula for maximum height? H is equal to U square sine square theta by 2G. So substituting U is 280 square into sine 30 is 1 by 2 square, and we get 1 by 4 divided by 2 into what? 9.8. It's an easy calculation. You can try. The answer is 1000 meter. So if you are doing this, 1000 meter, you'll get You can take GS10 and approximate also. So a close answer you can take because there is no very closer options are not there. So you can take GS10 and approximate. The answer for this question is option 2, that is 1000 meter. Clear? Right. I'm going to the next question number 24. The net magnetic flux through any closed surfaces. Direct, very simple. See, you just look at the question paper. One question was like electric flux is 0. Now here, magnetic flux through any closed surface. Gauss theorem in magnetism. What is it? The total magnetic flux passing through any closed surface is 0, right? You know the reason. Monopole does not exist, right? So the answer is what? 0. Very simple question from magnetism. 0. Okay. Now, the next question number 25. The equivalent capacitance of the system shown in the following circuit is simple again. Combination of capacitors. See, you can see that this capacitor and this capacitor are in parallel. So in parallel combination, what is the formula? In parallel, we can add them. So 3 plus 3 will be 6. So we get already one 3 is here. This is 3 microfarad. And this 3 and this 3 get added up. We get 6. So 6 microfarad. It's like this, right? Now you can see these two capacitors are in series. In series combination of two capacitors, we have a direct formula. What is it? C1, C2 by C1 plus C2. So what we get? 3 into 6 by 3 plus 6. So we get 18 by 9, 2 microfarad. 2 microfarad. Okay, so the answer for this question is 2 microfarad. Okay.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, Neet, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.